Hey everyone, I just wanted to make a video on solving trig equations based on the hand method. Now we have to remember that the hand method for equations will only work if your answers are the reference angles of 30, 45, 60 or on your quadrant or on your axes 0, 90, 180, 270 or anything in radians that's equivalent to those. So first thing I want to show you, we're going to solve all these for the principal values and then for all values. So I'm going to show you the two different things that they will ask you. Remember that the principal values, we can use this to memorize what values are actually the principal values. Quadrant 1 and 2, or from 0 to 180, is where our principal values are in cosine. Negative pi over 2 to pi over 2, or negative 90 to 90 is for sine, and then you can see cotangent and tangent. Alright, so we're going to solve a few of these. So, forgot my x here. I'm going to solve for x. So we are looking for the angle that would, when I take the tangent of that, would make that equation true. So let's isolate the variable first. Add the 3 to one side, then divide by negative 3. You get tangent of x equals negative 1. So you can, at this point, look at your unit circle. You can draw a triangle if you would like to. Once you start doing a lot of these, you'll start recognizing that these numbers over here show up a lot. Like you can determine which angle you might be looking at. So negative 1 for tangent. What, when I do y over x, would give me negative 1? So what angle, when I take the tangent of that, gives me negative 1? So I think about my hand measures, and we know that we've got 0, 30, 45, 60, 90. If I was finding the tangent of something, then it would be the y coordinate over the x coordinate. And I remember when I pull this finger down, if I pull this one, I have the x coordinate and y coordinate. So if I pull this down and I do the y over the x, remember I have square roots on these, so square root 1 over square root 3, that's not going to be it. Here I would have the square root of 2 over square root 2. Now square root 2 over square root 2 would give me positive 1. So now I have to find the quadrants where it would give me negative 1 instead of positive. And tangent, we had this acronym, A Smart Trig class. Tangent is negative here and here. So we get the 45 degrees in those specific quadrants. So your x could either equal 135 degrees or 315 degrees. Now those are the values I get just by using my hand in the quadrant. Now how do I solve for principal values? Well, I'm solving for tangent, and the principal values are found in quadrant 1 and quadrant 4. The only one in quadrant 4 would be this one. So the 135 would go out. Even though it's a solution, it's not a principal value in this particular example. So this would be the principal value solution, and then all solutions. Okay, so when I'm talking about all solutions, so this would be a separate question. The question would either ask you for the exact or all. Excuse me, the exact, which is principal values, or all the values. So if I had found all of them, I would have to incorporate that 135 back into my answer and the 315. Okay, so there's two ways I can do this. I can add plus 2 pi, or excuse me, we're in degrees, so 360k, where k is an integer, and then I could do plus 360k here, where k is an integer. That means I can just add 360 degrees and keep getting its coterminal angles, which means the same reference angle. So the tangent is a little bit different. We could do all this way, but most of the time, I'll put it right here, all of those, you could put x could equal 135 degrees plus 180k. Because 180k would get me from here to this quadrant and from that quadrant to that quadrant, depending on what that k is. So if it's 1, it would be a half. It would go 180 degrees, and if k was 2, it would go 360 degrees. Now, so let's recap here. This is your principal value answer if it's in degrees. If it's in radians, that's going to be 7 pi over 4. Okay, so dependent upon what your question asks, which method it wants, the degree or radians, depends on which answer you would choose here. Here it's the same thing. You could do the 135, which is 3 pi fourths. So it could be 3 pi fourths plus, I'm running out of room here. Let me put it here so you can see it. It could be 3 pi fourths plus, down here we could do 2 pi k, or 7 pi fourths plus 2 pi k. Or you could just do the 3 pi fourths plus pi k, which would be equivalent to this in radians. So this is all of your answers in radians. This is all of your answers in degrees. This is all your answers in degrees, and this is all in radians. You wouldn't need both of these. More than likely, you're going to see these top two when it asks for all of them. But again, the principal values are different. For tangent, it's only in the first and fourth quadrant. Okay, let's do another one. Let me get me an eraser. Okay, my next problem, let's do 2 cosine of x equals negative square root 3. So again, we're going to find the principal value, and then we're going to find all the values. So if I solve for x, that's what I want to do. I want to eliminate x. So cosine x equals negative square root 3 over 2. So at this point, you can check your unit circle and find the cosine where you have a negative 3 over 2. So that would be the x coordinate in those ordered pairs. Or you could use your hand. Cosine, remember, is the x coordinate over this 2. And remember, whatever finger you bring down, that's your comma. So if I wanted cosine, the x coordinate, it would have to be these 3 if I pull this down. So my angle's actually going to be 30. Okay, so it's the square root 3 over this 2. Square root 3 over 2. That's what I wanted to get. But I wanted to get it negative. I wanted to have a negative one. So, a smart trig class. Where is my cosine negative? It's positive here and here, so it's negative over here. So if I'm looking for a 30-degree angle, I would be looking at 150 degrees. Okay, which is 5 pi sixth, or it would be 210 degrees, okay, which is 7 pi sixth. Those are my options for the principal values, because it's in that first rotation there, it's in these 2 quadrants. So right here in these 2 quadrants, cosine would be negative, which is what I need. So now let's look at these. Cosine principal values are found in quadrant 1 and quadrant 2. So this one is thrown out. It's only thrown out when I'm solving for the principal values. I'll pick it back up here when I solve for all values. So now let's solve for all values. Here's my principal value. Depending on what mode you're in, degree or radian would determine your answer there. So for all values, X could equal 150 plus 360K. That's in degrees. You could have 210 plus 360K. K being an integer. So there's your two answers in degrees. And in radians, you would have 5 pi 6, 7 pi 6. You would add 2 pi k to both of those. So 2 pi k to both of those. Okay? Alright. Okay, we're going to do one more. Okay, and the last one we're going to do is 4 sine of x plus 4 equals 0. Now if we try to solve for x and get x by itself, we want to eliminate that sine of x first. Subtract the 4 and divide by 4, we would get -1. Now, -1 is the sine of some angle. So sine, remember, is your y-coordinate over this 2 if I use my hand. If you use the unit circle, check out the unit circle. Find where your y-coordinate is -1 on your unit circle. -1 here, the only way I could get 1 in the y is if I pulled the 30 down, but that would have to be 1/2. Because remember, you have to do the square root of 1 over 2. So right here, I know I've got to think about these axes. So this is 0 angle, which is a ordered pair of 1, 0. This is 0, 1, -1, 0, and 0, -1. So I'm looking for when the y-coordinate is -1, and that would be here. Okay, so my x value could be -90. It could be 270, so whichever way you want to look at it at that point. But we're looking for the principal values first. The principal values for sine are from -pi/2 or -90 to +90. So the one that I would need to use is this one right here. -90. So x equals -90, or in radians, that would be equivalent to -pi/2. Okay, that's the principal value. So depending on what mode you're in, degree or radian, there's your answers. And then finding all the answers, you would do -90 plus a 360k, where k is an integer. You could do 270 plus 360k, where k is an integer. It doesn't matter there because -90 and 270 are coterminal. Or you could do -pi/2 plus 2 pi k, because that's one complete revolution. You can put this, or you could put 3pi/2 plus 2 pi k. If these two are coterminal, then it's the same answer. If these are coterminal, it's the same answer, because when you put an integer in for k, you can get either one of those. So there's all the values. So I hope that helps solving trig equations using the hand method without using the unit circle. If for some reason you can't find these exact values, that means it's just like the unit circle. If it's not on the unit circle, you have to use the arc cosine, arc tangent, arc sine to find that specific angle. I hope that helps.